Hello and welcome. We're glad you joined us. I'm Georgia, a lead technical trainer here at Microsoft. In this session, we'll cover an introduction to security, compliance, and identity concepts. This builds the foundation for understanding how modern organizations protect data and manage access by exploring core ideas, such as the shared responsibility model, zero trust, data residency, and the role of identity providers. So let's get started with this session. This session is split into two parts. First, we will go through the security and compliance concepts, and then we will move on to identity. Let's begin with foundational security and compliance concepts. In this part, we'll explore the core identity, security, and compliance concepts that form the foundation of modern cloud security. You'll learn how key models and principles like shared responsibility, defense in depth, zero trust, and basic compliance work together to protect organizations and their data. The shared responsibility model is a must-know for anyone working with a cloud and explains how security and compliance duties are divided between the cloud provider and the customer. The key idea is simple. Who is responsible depends on where your workload runs, on-premises or in the cloud, as IaaS, PaaS, or SaaS. When everything is hosted on-premises, the organization manages all aspects of security, from the physical data center and network to the operating systems, applications, identities, and data. As you move them into the cloud, some responsibilities shift to the cloud provider, but they never disappear entirely for the customer. So no matter what the service type is, customers always retain responsibility for the data, devices, and identities, which is a critical point to remember. Now, to understand this, think of cloud computing like getting a pizza, where how much work you do depends on how you order it. On-premises is like making pizza completely at home. You buy the ingredients, prepare the dough, bake it, and clean up. In IT terms, this means your organization is responsible for everything from the physical building and hardware to the operating systems, applications, and data. Nothing is shared, and all security and maintenance is up to you. As we move to the cloud, that responsibility gradually shifts. Infrastructure as a service is like buying a pizza base from the store. The cloud provider then supplies the kitchen and the oven, meaning the data center, servers, and networking. But you can still add toppings and bake it, meaning you manage the operating systems, applications, and data. Now, platform as a service is like ordering a partially prepared pizza. The provider handles the infrastructure, meaning the oven temperature, which is the runtime in OS in the data center, so you can focus on your toppings, which is your applications and data. Finally, software as a service is like having a fully cooked pizza delivered to your door. The provider handles everything, and your responsibility is simply deciding who gets a slice, protecting the data, managing the users, and securing their devices. Now, this model helps organizations clearly understand what they must secure at each level and avoid risky assumptions about cloud responsibility. Now, let's talk about defense in depth. Defense in depth is a security strategy, like an onion, that protects systems and data by using multiple layers of protection instead of relying on a single barrier. So, rather than assuming one control, like a firewall, will stop every threat, defense in depth spreads security across layers such as physical security, identity and access controls, perimeter protection, networks, compute resources, applications, and finally, data. An attacker has to peel through many layers before reaching what really matters. Each layer has a specific role, and together they slow down attackers and reduce the impact of a breach. So if one layer is compromised, the next layer is designed to catch or limit the attack, keeping critical data and systems protected. Now, this approach is used everywhere in modern IT environments. For example, access to a data center is restricted to authorized personnel, which is physical security. Users must prove who they are with methods like multi-factor authentication, which falls under identity and access. Networks are segmented to limit movements around the perimeter. Virtual machines are locked down at the compute layer. Applications are hardened against vulnerabilities, and finally, sensitive data are encrypted in the data layer. The benefit of defense in depth is resilience. It reduces the risk of a single point of failure and gives us time to detect, respond, and stop attacks before real damage occurs. Now, this layered model forms a core part of an effective cybersecurity strategy and directly supports the goals of confidentiality, integrity, and availability. Now, in the previous slide, we talked about the concept of defense in depth, okay? But all of those different mechanisms are actually elements of a cybersecurity strategy, whose goals include ensuring confidentiality, integrity, and availability, often referred to as CIA. The CIA triad describes the three core goals of any cybersecurity strategy, whether they're on premises or in the cloud. Confidentiality is about making sure sensitive information is seen only by the right people, using controls like access permissions and encryption. Integrity focuses on keeping data accurate and trustworthy, ensuring it hasn't been altered accidentally or even maliciously. Availability ensures that systems and data are accessible when authorized users need them, because data that's secure but unavailable is still a business problem. Now, together, these three principles help organizations think holistically about security instead of focusing on a single area. In practice, the CIA triad helps organizations design and evaluate real-world security measures. So, for example, encrypting data supports confidentiality, but you also need to protect encryption keys and ensure authorized users can still access the data. As a result, linking confidentiality and availability. Integrity is supported through controls like hashing, validation, and auditing, which help confirm the data remains accurate from creation to use. Availability is addressed through redundancy, backups, resilience planning, so systems stay online even during failures or attacks. The key benefit of the CIA model is balance. Focusing on only one goal isn't enough. Security works best when confidentiality, integrity, and availability are considered together, giving organizations a clear framework to manage risk, while still enabling the business to operate effectively. A very modern security approach is the zero trust model, which is built on a simple but very powerful idea. Never trust, always verify. So instead of assuming everything inside a corporate network is safe, zero trust treats every access request as potentially risky, whether it comes from inside or outside the organization. It works by continuously verifying identities, devices, and access requests using all available signals. For example, a user's identity, device health, location, behavior even. This model is guided by three principles. Verify explicitly, use least privileged access, and assume breach. Together, these principles help organizations limit access to only what's needed and reduce the impact if an attacker gets in. Zero trust is applied across 6 foundational pillars: identities, devices, applications, data, infrastructure, and networks. For example, users may be required to use multi-factor authentication to prove who they are. Devices must meet security requirements before accessing resources, and networks are segmented to prevent attackers from moving freely. Data is classified, labeled, and encrypted, so it stays protected wherever it lives or travels. Now, the benefit of zero trust is stronger and more adaptive security that fits today's cloud-first, mobile, and hybrid environments better than previous techniques or models. So instead of relying on a single network perimeter, organizations gain better visibility, reduce risk, and the ability to protect users and data no matter where they are. Based on zero trust and the idea of trust no one, verify everything, the next question is, how do we protect data itself? no matter where it lives or how it moves. That's where encryption comes in. Encryption is the process of turning readable data into an unreadable format so that only authorized people or systems can access it using the correct key. In real life, encryption protects data at rest. That means when stored on disks or databases, in transit, which means that while it's moving across networks, and even in use, and that means while being processed in memory. These protections ensure that even if data is intercepted or stolen, it remains useless without the proper keys directly supporting confidentiality in a modern security strategy. Encryption works by using two main approaches. Symmetric encryption uses the same key to encrypt and decrypt data and is efficient for protecting large amounts of information. Asymmetric encryption uses a public and private key pair and is commonly used for secure communications such as TLS, for websites and digital signing. You'll see encryption used everywhere, from securing customer records in databases to protecting emails and web traffic to safeguarding sensitive workloads in the cloud. The benefits we get is strong built-in protection that reduces the risk and supports compliance requirements most of the time. It will also help organizations confidently use cloud services while keeping data secure wherever it's stored, transmitted, or processed. While encryption protects data by making it unreadable without a key, the next concept focuses on protecting data in a different way, called hashing. Hashing takes an input, such as a password or a piece of text, and runs it through a mathematical algorithm to produce a fixed length value, which we call a hash. One important characteristic is that hashing is deterministic, meaning the same input always produces the same output, the same hash, and is one way, meaning the original data can be reconstructed from the hash. So unlike encryption, there's no decryption step, which makes hashing especially useful as a secure identifier rather than a way to recover data. So in practice, hashing is most commonly used to protect passwords. So instead of storing the clear text password, systems store only the hashed version. So when a user signs in, the entered password is then hashed using the same algorithm, and then we compare these two hashes. If they match, access is granted. To reduce the risk of brute force or dictionary attacks, passwords are often salted, meaning a random value is added before hashing, so identical passwords don't produce identical hashes every time. The benefit of hashing is strong protection of sensitive credentials, reduced impact if the data is exposed, and better security without the need to manage encryption keys for everything. And it's a foundational technique in modern identity and access systems. Hashing and encryption, however, protect data at a technical level. Let's zoom out to look how we can manage security and compliance at the business level. This is where governance, risk, and compliance, or GRC, comes in. GRC provides a structured way for an organization to set rules, understand threats, and meet legal or regulatory obligations. Instead of reacting to problems after they happen, GRC helps organizations plan ahead, define accountability, and make informed decisions about how security supports these business goals. From a practical perspective, governance defines how an organization is directed and controlled through policies, standards, and of course oversight, such as who can access data, who has admin rights, and how actions are monitored. For example, a company defines a policy that all cloud resources must be tagged with an owner and business purpose, so leadership can track accountability and enforce standards. Risk management focuses on identifying and responding to events that could impact the business, from cyber attacks and data leaks to internal fraud or external disruptions. For example, an organization identifies the risk of data loss from unsecured storage accounts and mitigates it by enabling encryption and access controls. Compliance, finally, ensures the organization follows required laws and regulations, including data protection, privacy, or any industry-specific standards. For example, a company operating in the European Union implements controls to meet GDPR requirements by restricting access to personal data and logging all access activities. So the benefit of GRC is clarity and consistency to help organizations reduce risk, avoid penalties, and build trust with customers by aligning people, processes, and technology around a shared framework for security and compliance. So, with governance, risk, and compliance in place, the next focus is identity, which is knowing who is accessing systems and what access they should have. As organizations move to cloud services and support remote work, the traditional network boundary is no longer enough. Instead, security starts with verifying who or what is trying to access resources. In this section, we'll explore how identities apply, not just to people, but also to devices, applications, and services, and why managing them correctly is critical. We will also look at how identity-related services help organizations control access, reduce risk, and improve visibility. This includes understanding how identities are created and managed, how users are authenticated, and how access is granted and monitored. By the end of this section, you will see how strong identity services form the foundation for secure access in a modern cloud and hybrid environment by making sure the right entities get the right access at the right time for the right reasons. So, as identity is becoming the new security perimeter, let's talk about how identity is actually enforced through authentication and authorization. Authentication is about proving who you are. It answers the question, are you really who you claim to be? And typically happens when you sign in with a username and password or provide additional proof, like a one-time password or biometric. Once your identity is verified, access can begin. In everyday terms, authentication is like showing your ID at the hotel reception or airport security. It confirms your identity before anything else can happen. After authentication comes authorization, which determines what you're allowed to do once you're signed in. Authorization controls the level of access you have to data, applications, or systems. For example, two users may successfully authenticate to the same system, but only one may have permission to edit files or access sensitive information. This separation is powerful because it supports the principle of least privilege. Users get only the access they need, nothing more. Together, authentication and authorization help organizations protect resources, reduce risk, and make sure the right people have the right access at the right time, which is essential in a modern cloud or even a hybrid environment. After understanding how authentication proves who you are and authorization defines what you can access, then the next step is to see why identity itself has become the center of modern security. Identity is now the primary security perimeter because access to applications, data, and systems no longer depends on being inside a corporate network. Users work remotely, devices connect from anywhere, and applications live in the cloud. An identity can represent a user, a device, an application, or a service even. And each identity must be verified and controlled before access is granted. This shift reflects how organizations secure cloud apps, partner access, personal devices, and on-premises systems through a single, consistent identity layer. To manage that identity securely, organizations rely on 4 key pillars of an identity infrastructure. Administration focuses on creating, managing, and maintaining identities across users, devices, and services. Authentication ensures enough proof is provided to confirm an identity. often using strong methods like multi-factor authentication. Authorization determines what the authenticated entity is allowed to do, applying the least privileged access to protect resources. And finally, auditing tracks who accessed what, when, and how, providing us with visibility, alerts, and governance. For example, IT creates and manages user accounts, assigns roles, and sets access policies when a new employee joins the company. When the employee signs in, they prove who they are using secure sign-in methods such as a password and even multi-factor authentication. Now, after that process, the employee is granted access only to the applications and data required for their job role. And all these sign-ins and access activities are logged so security teams can review that activity and investigate any suspicious behavior. So together, these 4 pillars helps us reduce risk and improve accountability. And of course, secure access across our cloud and hybrid environments where identity is the new security boundary. Building on identity as the primary security perimeter, the next step is to understand how modern authentication works and why the identity provider plays such a central role. Modern authentication is a set of secure sign-in and access methods used between a client, like a laptop or phone, and a server, such as a cloud application. At the center of this model is the identity provider, or IDP, which is responsible for verifying the identities, granting access, and tracking that activity. So instead of each application handling sign-in separately, authentication and authorization are handled centrally, making access more secure and consistent across services. An identity provider enables scenarios like single sign-on, where users sign in once and securely access multiple applications without repeated logins. It also supports stronger protections, such as multi-factor authentication, federation with other identity providers, and monitoring for any suspicious behavior. This means organizations can apply access policies, reduce password-related risks, and gain better visibility into who is accessing what. So the benefit here is to get improved security, better user experience, and simpler management, especially in cloud, but also in hybrid environments, where users, devices, and applications are no longer limited to a single network. Now let's move to understanding where identities are stored and managed. Directory services provide a structured way to store information about users, devices, and other objects on a network. A directory acts like a central address book that applications administrators and services can rely on to look up their identities, verify credentials, and understand their access rights. A well-known example is Active Directory, which is Active Directory Domain Services, which has long been used in on-premises environments to manage users and devices from a single centralized location. It enables organizations to authenticate users, control access to resources, and apply consistent policies across their IT environment. So as organizations move to the cloud and adopt software as a service or SaaS applications and mobile work, directory services and identity management systems had to evolve. Microsoft Entra ID represents this evolution by providing identity as a service across cloud and on-premises environments. It supports modern authentication methods, it works with cloud applications, and integrates with existing on-premises directories. Use cases include enabling single sign-on, securing access to cloud apps, and supporting all remote and mobile users without relying on a traditional network boundary. So we get centralized identity management, better security through modern authentication, and the flexibility to support hybrid or cloud-first environments while still keeping our identities under control. So once modern authentication is established through identity providers, we can now look at how identities can work together across organizations through federation. Federation allows one system to trust another identity provider so users can access applications without creating new accounts. Now, in this model, an application relies on its own identity provider, while the user authenticates with a different trusted identity provider. Because a trust relationship is in place, the application accepts the user's identity and grants access, creating a seamless sign-in experience without sharing passwords. In practice, federation is commonly used when signing into a third-party website using an existing account, such as work or social identities. For example, a company hosts a web application that uses Microsoft Entra ID as its identity provider. A partner organization uses a different identity provider. A trust relationship is configured between the two identity providers. So when a partner user signs in using their own organization's credentials, the application trusts the authentication and grants access without creating a new account. So that brings us a lot of convenience for users and also stronger security for organizations, since credentials stay with the original identity provider. Federation also supports business collaboration by enabling partner, customer, or external user access without duplicating identities. This approach reduces administrative overhead, improves the user experience, and supports secure access across cloud and hybrid environments, where identities often span multiple systems. Now let's bring together everything we explored across security, compliance, and identity. In this video, we learned core security and compliance concepts, such as the shared responsibility model, defense in depth, how the CIA triad defines cybersecurity goals, the guiding principles and 6 foundational elements of the Zero Trust model, and the basics of governance, risk, and compliance. We also explored key identity concepts, including authentication and authorization, that places identity as the new security perimeter, and the role of identity providers, directory services, and federation. Now, together, these topics show how we use layered security, clear responsibility models, and strong identity controls to reduce risk, meet compliance requirements, and securely enable users, devices, and applications in modern cloud and hybrid environments. The next video in this series builds on identity foundations and dives into how Microsoft Entra turns concepts into real capabilities. We will explore how Microsoft Entra ID connects people, devices, and applications using secure authentication, access management, identity protection, and governance. You will see how features like multi-factor authentication, conditional access, role-based access control, and identity governance are used to protect, to access and reduce risk, and support modern cloud and hybrid environments. This learning path shows how organizations move from understanding identity to actively securing it at scale, making identity a powerful enabler of both security and productivity. This concludes our session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching, and remember, stay informed, stay resilient, and stay protected.